don't have to go through this. You guys don't want to.
No, it's alright.
But I thought it might be helpful, so. Okay. We have done problems like this one. Actually, several types of these. So hopefully we'll start to recognize some patterns here. The rate at which raw sewage enters the treatment tank is given by this function. Now, this function is a what type of function? An original function, a derivative, or a second derivative? Yeah, if you see the rate, every time they throw that word rate in there to identify that that is a derivative function. It's not labeled a derivative, but we have to treat it as a derivative. Because derivative is rate of change, so we need to make sure that we identify that. Remember that they throw words in there to specify things about that function. So, Chase?
Where is this implemented?
This is on the test that we did last week in class.
The actual college board one.
Yeah. All right. So that's the rate that it enters a treatment tank per hour, from 0 to 4 hours. Treated sewage is removed from the tank at a constant rate of 645 gallons per hour, and the treatment tank is empty at time equals 0. All right, for A, and notice that this is a graphing calculator question. How many gallons of sewage enter the treatment tank during the time interval from 0 to 4? Round your answer to the nearest gallon. Now, we are only looking for how many gallons enter the treatment tank. And this is the function of stuff that goes into the treatment tank. Not what's taken out, but what enters. And when it asks the question, how many, what are we supposed to do to that function? Integrate it, because we're accumulating gallons of raw sewage, apparently. Okay. Now, we are going to integrate from 0 to 4. Because this is a calculated part, please do not try to integrate this by hand. It'll waste time because you don't have to integrate it by hand. When I set this problem up, I don't even waste time to write out what E of t is. I just write E of t. They've defined what it is. By me just writing E of t dt, I'm showing them that's what I'm integrating. So, you'll put it in. Everybody should be trying this on their own. Yes, everything's in radians.
Whatever happened to those commas that you're supposed to put in thousands of years? And you can use either the crisscross
Oh,
parenthesis around the pi x squared.
thank you. Okay. That's what you have?
I got an error. That's what I got.
That's what you should have. Okay, make sure. Okay, listen. If we're gonna get through all 6, then when I'm talking, if you have a question, raise your hand or something. But please don't just talk for the sake of talking. If you're getting different answers than me, I'm getting the right answers. So I'm trying to show maybe where you're.
Oh, radians.
Yeah, now it's like loading or whatever, but it's
Make sure that when you have a fraction, like here, just make sure you have parentheses around the top of the fraction in your calculator. But we're going to round. Does it say to round? Yeah. Round your answer to the nearest gallon. So if my answer is this, the nearest gallon would be 3,981. And make sure you write your units.
really quick. Why do you use n as 100?
I just always pick 100. Okay. Yeah. Okay, for B. For 0 to 4, at what time is the amount of sewage in the treatment tank the greatest? So I'm looking for I'm looking for max or min, right? I'm not looking for average anything because I don't think. Well, maybe it does. Nope, it doesn't. Yeah, if the word average isn't in there, we're not trying to do the average amount. But it just is asking for the greatest amount of sewage. So we're looking for a max in the original function, which is where the derivative equals 0. So we're probably going to do that at some point. To the nearest gallon, what's the maximum amount of sewage in the tank? Now, when we set this up, we're going to just name a new function here for the amount of sewage that would be present, like basically setting up the integral here. I'm going to let S of t, you can use whatever you want. I'm using S for sewage. Okay? Be the amount of sewage. And then we're looking for the maximum where the derivative, now we can't just take E of t and set it equal to 0. We have to look at the original function. That's why I'm trying to make this original function. Hold on. Let me finish my train of thought. And then, so then the rate S prime of t would be the amount going in, which we already know the rate of the amount going in is that function E of t, minus the stuff going out, which is how many gallons? 645. And that's a constant rate, so it's just 645. But that would be the original function. We might get to that point. Because it tells me that 645 is the constant rate that it leaves.
That's okay, I didn't see it either.
Now, the reason we have to set up, and we did a problem like this before, we have to see where S prime will equal 0. It's not where E of t equals 0. It'll be where this equals 0. Now, where this function will equal 0 is when E of t is what? 645. So 645 becomes our new baseline, or our new x-axis. So we're going to use the function that we have, and we're going to find where E of t not equals 0, but equals 645. Again, the reasoning behind this is you need the amount, you need to find the max, which we know to find the max you have to take the derivative and set it equal to 0. But the original function isn't E of t. The original function is S of t. And then the derivative of S of t, which is what we would have to set equal to 0, is the amount coming in, the rate of the amount coming in minus the amount going out. The rate. And so where E of t is equal to 645, that is where my S prime will equal 0. Does that connect? Okay. So we're going to take E of t, that function here, and set it equal to 0 and find where that happens. Now, again, this is the calculator portion, so probably what we're going to do is graph E of t and graph the line 645 and see where they intersect. I think there's two answers. 2.309 is one of them.
But it's looking for a maximum. From 0 to 4?
But I think you have to identify all the possibilities before you can say.
What window are you using?
Yeah, what window are you using? Sorry.
Me?
Yeah.
0 to 4, and then soon fit. Y max I have 1565, and Y min I have 135 point blah 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 blah. And a whole bunch of junk.
That doesn't help. Okay. Okay, this should get me what I need here. Okay, the reason I went to 0 to 4 is because that's the time interval, and so I'm going to identify the 2. Now you can see from here that the only max possibility I have, my two critical numbers are 2.309, which is what I think TJ found here at the intersection. Yep. Because the derivative here would change from positive to negative, that would be a maximum. This one would be a what? Be a minimum. So 2.309 is our candidate. Now, if we need to find does it say the absolute max?
No, it just
Just
says
the maximum amount total? Yeah?
yes.
Probably because you're in degree mode instead of radian. I'll check it in a minute. I think that's all you'd have to. Yep. Okay. So they have a lot more work there, and usually if it's asking for a maximum and if it doesn't identify a relative maximum, that means you have to check all of your points. We don't have to check this one because we know that that's going to be a minimum, but I would have to check the endpoints. So we know, like, let's make a little t-chart here. T hours and then amount of sewage. At 0 hours, how much sewage did I have? 0, because it told me at the very end of my little paragraph up here. And then at 2.309, that's a possible maximum. And I'm going to use my calculator to figure out the amount of sewage at that time. And then I also have to identify, if I'm looking for the absolute max, I have to check the endpoints as well. So you identify the possible max or mins in the middle, and then check the endpoints. So we're going to go... the trap rule, I'm going to go from 0 to 2.309 and figure out how much.
Wait, what? Are we on C?
What?
What are you doing?
No, we're still on B. I'm looking for the maximum amount of sewage.
Should we be finding the accumulation of value from 0 to 2 then? Or 2.309?
Yeah, that's what I'm doing.
Well, then wouldn't the maximum amount of value be from the beginning to the end because you're accumulating all that value?
But some of it was taken away. Remember, because it dipped below?
Oh.
Okay.
But that's not factored into the y equals, is it?
Do we have to do S of
There's
T
no
then?
minus 65 in our y.
Hold on.
Like, I don't...
Hold up, yo.
Oh, you know what?
That's fine.
We'd have to integrate from 0 to 2.309. And then when you subtract the 645 per hour, yep. That's where I knew it was going to come in here at one point. Because you have to subtract what was taken out per hour. So the accumulation of value there, just of what's coming in, is that. And then we have to subtract 645 times 2.309. And then that would be the amount.
Which they asked us to find?
Because you have to find the maximum.
They asked us to find it though, right?
Yes.
Okay.
Yep. Because they do tell you to the nearest gallon what's the maximum amount. So we do have to find the maximum amount.
For this interruption, but softball and baseball have been canceled. We're not sure about practices as of now.
Why?
It doesn't matter. Okay. I mean, it matters, but probably because of rain. Alright, so... And then for 4, we're going to accumulate value from 0 to 4, and then subtract what was taken out to get the amount.
I got 16%.
Oh, I messed up because I have negative numbers.
Change that again.
So these are floating points. Why do we have to find it at 4?
Because you have to check the endpoints as well.
Oh, never mind.
Why do we have to check the endpoints?
That's just what you have to do.
Wait, what do you mean check the... Wait. So from 0 to 0?
No, from 0 to 4. Because your endpoints are 0 to 4. It told you at 0 times 0 you had 0 amount of sewage. I told you that in the very beginning.
Okay.
So that was checking one endpoint. It was already done for you. Then you have to check the other endpoint.
Using that, like integrating?
Yeah, that's take the pencil and talk
No,
about it.
Well, yeah.
because you accumulate value from 0 to 4 to see how much went in there over the course of 4 hours, and then you have to subtract what was taken out.
Kind of see if more work between the 0 and 0.309.
This is just a relative max. This might not be the absolute max. That's why you have to check the endpoints as well.
Oh, my graph knows the debt, so that's what it's probably.
Okay. Now, in this case, you do find the maximum amount at 2.309. If you do not check your endpoints, you lose 1 answer point in this. So you do need to check the 0 and the 4. But if you just check that and it ends up being the one that has the maximum amount, they'll give you your answer point. And I think it tells you to justify your answers. So basically you just have to write that in words. That the amount of sewage is greatest, because they ask you 2 things. They ask what time is the amount of sewage greatest, so you have to identify if the amount of sewage is greatest at time equals 2.309, and that's hours, right? Yep. And then they also ask you to identify the amount, the actual amount. So you'd say at that time, the amount is whatever it was, 1,637.13 gallons. Oh, and they ask you to round to the nearest gallon. Oops. So we don't need the 0.113. Alright, and then the last one, total cost. From 0 to 4, the cost of treating the raw sewage that enters the tank at time t is 0.15 minus 0.02 t dollars per gallon. To the nearest dollar, what's the total cost of treating all the sewage that enters the tank during the time interval 0 to 4?
So since we found 0 to 4 at the end, or since we checked the endpoint, we just take that and multiply it by the cost.
We have to set it up as an integral though, so we show that we're evaluating from 0 to 4.
Do you have to back the square the
E of t dt. Huh?
Do you have to like just not square that exactly?
Like this right here?
No, like the amount, like the data.
Yeah. To show that.
If we don't, are they gonna like?
Not necessarily. If it's not crossed out, they look at it to assign points. So if you forget to box something, it's probably fine. Yeah, and then you would multiply whatever that answer is by 0.15 minus 0.02. 0.02.
Wait, what about the
T.
minus 645?
It's just the total amount, not the amount integrated.
Yeah. They don't care about what you're taking out. They just ask the total amount that comes into it. So the function that you actually put in needs to be changed to be 0.01. I'm probably going to put that in parentheses. 0.15 minus 0.02 t. Oh my word. T. And then times the function that you had. So 850 plus 715.
What? You can't see anything you're doing on here, right?
Oh, that would have been nice.
Why do we multiply that? Because I didn't think we were integrating that as well.
You have to accumulate cost as well.
What? I'm 3,000.
So basically, you don't integrate from 0 to 4 et dt. You have to integrate from 0 to 4 et times 0.15
Yes.
minus 0.02 t then dt.
Yes.
Let me make sure I'm reading this right.
The reason being because they give you the cost in dollars per gallon. That's a rate. So then if we run this program, or run the trap rule on that, from 0 to 4, that ends up being the cost. 474.33. Unless it tells you to round to the nearest dollar, so 474.
Show me what the Y is.
Yeah. It's just basically the cost rate times E of t.
It doesn't matter which.
It doesn't matter what way you put it. Oh.
Did you just insert that the beginning of the code
Yeah.
between it?
Yep. And that's all you need to do, because it doesn't tell you to justify, so you can just write your answer. Okay. I don't have any more. I don't think this one's going to take as much room. Now, like for number 2, it's nice when they give you an area problem on the calculator part, because then most of the work is done on the calculator. Alright. So they have R and S in the figure. R is the region in the first and second quadrants bounded by the graph of 3 minus x squared and 2 to the x. You do need to know that that's an exponential, and that function is your quadratic, which hopefully everybody will be able to identify that, just from knowing the shapes of both of those. S is the shaded region in the first quadrant bounded by those things. We're supposed to find the area of S. So,
You can't just do the top function.
I think we're going to have to go... No, I think we have to split it up into 2. We do. Because if I draw in a representative rectangle, the way it stands right now, this top function minus the bottom would be different than this top function minus the bottom. So we have to split it up into 2 and to integrate, which if I do that, I have to find that point where they intersect. Yes, sir?
Could you do the top function minus the bottom function for like the top unshaded region, and then do 2x minus 0 for the bottom region? Would that help?
That wouldn't work. Yeah.
That wasn't enough.
No, you have to look at just the shaded region that they give you, and then if there's not just one consistent top function, you usually have to split it up into 2 pieces. So we're going to look at this like as 2, and then add up the integrations. So you're going to integrate from 0 to whatever that intersection point is of 2 to the x, which the bottom there would just be 0, so we don't have to include that. And then you add from whatever that intersection point is to, where it connects to the x-axis, which we'll have to find too, of the top function there, which is 3 minus x squared dx. Now, to find the intersections, I think we're going to have to at least put both these in our calculators. I would go to a normal window, so negative 10 to 10 on both. Then hopefully that'll give us at least places where we can intersect here. And let's first find the place where they intersect each other, which it looks like they intersect each other at 1.
Yep.
So we're going to go from 0 to 1, and then from 1 to, and then we got to see where it intersects the x-axis.
Can't you figure that out by just finding the 0 of the parabola?
You can, yes.
Parabola.
So 1.73, which, that's, I don't really want to round that. So
Square root 3.
maybe it'd be better, yeah, to find, because since that didn't come out to be a nice number, if there's another way to do it, if we round that right now, it might throw off our answers enough that we lose our answer point. So if there's another way to find that 0, which there is, if we set that function equal to 0, you get negative x squared equals negative 3, or x squared equals 3, or x equals square root of 3. So that's my other bound there. Now, in both these cases, I can integrate them separately. When you integrate them separately, I didn't know if you knew you could do this, but you can deselect the function you don't want to use.
Oh.
So like if you go over the equal sign, we don't want both of them to be integrated from 0 to 1. We just want the 2 to the x. So you can deselect the 3 minus x squared, so only the one that's selected will run in the program. So we're going to go from 0 to 1 and run the program. And you get 2.66665. And then we're going to add. I'm going to select the other one now and run the trap rule again from 1 to the square root of 3.
Are you sure that'll work?
Yeah.
Nope, she only went to school for a few years.
Because the other night I did problems and I did it and it didn't work by deselecting
I
the
think you might
function.
have done something wrong. You have that mistake now.
All right, so when we add it up, you end up getting 3 point...
Why did you have so many deciphers?
Yeah, it doesn't matter.
Why
You
did
want to
you
be
have
fat.
so many deciphers?
So because I don't want to round too much. Yeah. Until I get my final answer, I don't want to round as much. You could also store that answer. That probably would have been a better way to do it. But
Wait a second.
okay, and you end up getting, I forget the question or the answer I got there. 3.464. And that would be units, I think, just units squared. Okay, for B, to find the volume, that's A. We'll do B up here in the corner. Yeah?
Did you say you got 3.46?
Yeah.
Yeah, I got the exact same thing, but instead of doing all that, I just took 3 minus x squared and evaluated it, or took the integral and evaluated it from 0 to 1.7.
What?
3 minus x squared.
Yeah.
Took the integral of that and evaluated it from 0 to 1.7, which is where the parabola intersects the x-axis.
Yeah.
I got the exact same thing.
I got 2.239
But
Galen.
see, in doing that, I was doing like the way that I had thought of doing it, and I got that as that solution.
What's the integration for A?
Well, let me check the answer here that they have.
For A.
Now,
What's the integration?
this is how they've set it up. So I'm assuming maybe that way that you just said it was a fluke then. Because you do have to look at two separate things added up.
3.46. 3.46.
Okay, for B, find the volume of the solid generated when R is rotated around the horizontal line, y equals -1. If we were to draw a horizontal line here and then rotate this around, first of all, your slice would have to be perpendicular, right? And when you rotate it around, it's going to generate a washer, correct? So when you set up your problem,
Yeah, it's going to be a washer. Oh,
because you have this missing piece here. Yeah. So we're still going to have to look at it as two different sections here. Because again, your top function is going to be different for both washers. So the first one from 0 to 1. Remember your pi r squared minus pi r squared here.
Miss Cross,
Yes.
are you very sure about your answer for letter A? Because TJ's over here muttering that he's absolutely positive
I
about letter A.
really think that it only takes y1 per program. Because
Well, Miss Cross was
They wouldn't have
You mean
gotten
that maybe it was just the deselection thing?
she would have gotten
yeah,
66
like the deselection. I think you have to put it in y1.
Miss Cross has the
You
right
can try
answer.
it. Well, I didn't check the actual answer. I just checked the setup.
What's the actual answer?
I'll look in a second. I just want to see if I get the same thing. Oh, I did get something different. Yep, so sorry. You do have to just put in, for the programs, you just put in what you want to evaluate into Y1. So that, plus, I don't know if I can do that, 0.797428.
Miss Cross, that's exactly what I got doing my method.
you get 3.82
Yep.
No, what I said was
This is
3.46 was
2.24.
one section of the problem that I did.
But again, it would need to be set up this way. The way I set it up. The way you did it might just be a fluke. Depending on the shape, it might not work out
What I
next
wound
time.
up getting was, like, because I reduced the derivative to two different sections, I got 1.22 minus 3.46. And the 3.46 was the one section that I did.
Okay, I'll have to look at it and see how you set it up. Okay, yeah, TJ.
For B, have we gotten to the point where we have to rewrite the functions?
I haven't done anything yet for B hardly.
Okay.
So. Okay. You can go to the bathroom. There's no more tissue. Yep. Now, since we are... Oh, okay. I have to be careful here. This is not asking when S is rotated around the horizontal line, is it?
No, it's not.
It's when R. And R... Hold on. Which is going to make it better. Because R...
not my fault.
R is the region in the first and second quadrants, but it's only bounded. It's only this section here. So it's just top minus bottom, which is nice. It's not going to be two sections here. I was like, this is going to get really complicated. So I re-looked at it, and I should have just read more carefully. You're still going to have a washer when that region is generated, or when it is rotated around the line y equals -1. But we're not going to actually be from 0 to 1 then. We have to find where these two functions intersect each other over here, which since we already had them graphed,
It's from something to 1, isn't it?
yeah. So if we were to graph it again, we found the one intersection. We just need the intersection over here in the second quadrant. So when I do the intersection again, I'm just going to make sure I'm closer to that one. And so negative 1.636 is your intersection there. So we'll go -1. Let's go to 4 decimal places. Because remember, we don't want to round too much. All right. And then same thing. So this will represent my outer disk minus my inner disk. My outer disk is top minus bottom, and remember when you're trying to find your radius for your outer disk, the bottom is always the thing that you're rotating around. So top, in that case, will be 3 minus x squared when you write your radius. Um, 3 minus x squared, and then what's your bottom? Negative 1, so really you're just adding 1 there, because you're subtracting a negative 1. And then here your inner disk will be top minus bottom, but your top function will be 2 to the x minus the bottom will be your what you're rotating around again, so it'll be plus 1. Now, we don't have to simplify or anything here. We just need to integrate this, get a value, integrate this, get a value. So I'm going to clear out everything here and stick pi of 3, sorry, I could probably write 4, minus x squared squared. I'm going to evaluate that. So run my program. From negative 1.6365 to 1. It has to be f of b minus f of a. Yeah. So you get 95.429. And then we're going to subtract what I get when I get the other one. I feel like I'm doing all the work here, people.
Oh, I feel like I just plug it in and I totally get opposite of what you're saying.
I know. I hate plugging.
But you should still keep trying to plug it in and watch me while I'm doing it.
You should take our silence when you're not talking again.
Can you go back to your
Well, when I look up and I see people having their own conversations, I feel like I'm talking to
pull up
people
the
who aren't paying
Y,
attention.
Y,
The y equals?
yeah.
That's little subject.
Oh, I think I forgot to, all I did was
Forgot to square it.
yeah. Extra less.
So you get 32.328, and then if you subtract 95.429 minus 32.328, you should get 63.101.
Yay.
Cubic units.
Well, actually I got 102, but
That's fine. Okay. Are we ready to talk about the last one, or are you guys
Yeah.
quitting on me here?
No, I'm listening. Oh, it's because I got
I got
93, but
18.58.
Then that would be...
I got 93.
Oh, for C.
Quick class.
Yes.
Instead of 95.4, like 92 or 429, I have 92.7958. I mean, it's close, but
I'm not sure.
is like if we're close to the answer, do we get like partial points? Okay.
Okay, for C, the region R is the base of a solid. So now we're back to this region up here. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with one leg across the base of the solid. Write, but do not evaluate an integral expression that gives the volume of the solid. So we don't have to actually find the answer here. We just have to write the integral. Now, if we were to draw a representative rectangle there, that's telling that, or they're telling you that this is an isosceles right triangle where one leg is laying here. So it's like coming up off the paper where one side is a, well, I'll just draw the shape here. Isosceles means these sides are going to be congruent, correct? if we were to write an expression for this, what's the area of just a regular rectangle or triangle?
It's base times height, isn't it?
Right, for a regular triangle, it's base times height, 1/2 of that, right? But with an isosceles, your base and your height will be the same. So you can write it as 1/2 base squared, let's say. Okay? So when we write the integral here,
Why is it half base squared?
because your base and your height are the same.
How are your base and the height
Because
all
they're
the same?
Because they're isosceles.
But it's not always oh. Never mind, I didn't see the right.
Oh.
I was like, what?
Okay, so we have, well, it says write but do not evaluate integral expression. So we're going to have negative 1.6365 to 1, still as my connecting points, or what I'm integrating between. And my expression is not pi r squared now. It's going to be the area of the cross section, which is the isosceles right triangle, which we already said the area of that is going to be 1/2 base squared, right? And it's taken perpendicular to the x-axis, so we have a dx, which means my base has to be written in terms of x. But my base is top minus bottom. So that's how you would just have to put the 3 minus x squared minus 2 to the x in for b.
Once again, all
We'll pick up there tomorrow.
baseball games for tonight have been canceled. The soccer
You'd have
games
to write that,
will
yeah.
be played, JV at 4.
Oh, yeah, I can right now.
Varsity at 5:30. Varsity baseball and softball, you will have practice immediately after school.
Oh, Miss Cross.
Ethan, can
Said
you
that there's like
move to the office,
four
please?
people,
Drama
all four
students,
kids
please
or
go to
so
the stage.
walking around
Please
town
move after
by.
school today.
There you go.
Victoria Fletcher to the office.
I'm feeling pretty genius right now. See, this is what I did. 3 minus x squared, which is that, minus 2x, which is that, which will give me this section right here. And then I evaluated that from 0 to 1 because this intersects at 1.
Yeah.
And then I subtracted 3x squared, which is this. Subtracted, or, wait, yeah, which is the entire thing. And evaluated that from 0 to 1.7, which intersects right there. So you're pretty much taking this portion away from the entire thing, which gives you that. So I got the right answer doing that.
Oh, yeah, that was.
Yeah, and then when that's, this is the exact same thing that's right there, but I crossed that off when I thought the answer was 3.46. But what you did when you did that is you got this section right here.
Right.
Or you got the entire
I got the
section.
entire thing.
Yeah. Yep.
Good job.